Alright, so in this video, we're going to be going over your Chapter 6 exam review. So let's get started. Number 1, find all the real cubed roots of that number. Well, the easiest thing to do is this. First off, start by counting a number of decimal places. We have 1, 2, 3, 4, 5, and 6. We have 6 decimal places, which means our final answer, since we're taking the cubed root, is going to be 6 divided by 3, which is 2. So our final answer is only going to have 2 decimal places in it. So we can rule out those 2 right there. Alright. What we can also do, the cubed root of this number, okay, when you take the cubed root, you always end up with the same sign you started with. Alright, so like if you think about it, the cubed root of 8, positive 8, is positive 2, where the cubed root of negative 8 is negative 2. Alright, so if you started with a positive number, you're going to end up with only a positive number. If you started with a negative number, you're going to end up with only a negative number, which means you're not going to have 2 answers. So here the answer has to be A. And in fact it is, because we have 2 decimal places, and the cubed root of 27 is 3. So the 3 goes on the second decimal place. Alright. Number 2, find all the real fourth roots of this number. Well, now since we're finding fourth roots, we are going to have positive and negative numbers. Alright, because anytime you raise a negative number to an even-powered exponent, you always come out with a positive number. So which means we know we're going to have plus and minus. Well, this doesn't have any minus, we can cross this out. This doesn't have any minus, we can cross it out. Now, we're down to B and C. Well, if you notice, 16 over 49 is just 4 over 7. Negative 16 over 49 is just negative 4 over 7. What they haven't done here is square rooted these properly. So that's out. So the answer has to be B. And in fact it is, because the fourth root of 256 is plus and minus 4. And then the fourth root of 24/1 is 7. So we're good with that one. So number 2 is B. Number 3, what is the simpler form of the radical expression? Well, we start out by taking the fourth root of 81. Well, if you're having trouble doing the fourth root of 81, just ask yourself this. What is the square root of 81? Well, the square root of 81 is 9. Well, since you want the fourth root, you just take the square root twice. Square root of 81 is 9. Square root of 9 is 3. So we know our coefficient out front is going to have to be 3. So you can cross out B and C. So now we're down to, is it the absolute value of x to the 5th y squared, or x to the 5th times the absolute value of y squared? Well, alright. So since this right here, alright, since this is even and this is even, okay, so we have our index is even and our exponent here is even. When we take the fourth root of x to the 20th, we're going to have an even number, because those 2 are even. Alright? Anytime the index is even and your exponent is even, you're going to have to include the absolute value bars. Alright? So 20 divided by 4 is 5, so that means the answer is A, because you have to have the absolute value of x to the 5th. The reason you don't have to have it for the y squared is because a negative number squared will always be a positive number. So even though the exponent on y right here is even and this is even, alright, so even though those are even, we don't have to have absolute value bars, because y squared will always be a positive number. Alright. Number 4. Well, this one's easy. Since our indexes are the same, you just multiply the numbers inside. 11 times 3 is 33. 33 is not a perfect fourth root, so you just have to leave the 33 under the fourth root. So your answer is going to be D. Okay. Let's go to number 5. Number 5, here what you're going to have to do is distribute through the square root of 7x to both terms. So the square root of 7x times the square root of x comes out to x times the square root of 7, because the square root of x times the square root of x is just x, and then you're left with the square root of 7. minus 7, and then the square root of 7x times the square root of 7 is actually 7 square root of x, because 7 times 7 is 49, and the square root of 49 is 7. Alright? Or you can just look at it as the square root of 7 times the square root of 7 is just 7. And since we have this 7 out front, we're going to have to multiply those two 7s together, alright, which would then give us to the square root of 7 minus 49 square root of x. So your answer is going to be A. Right here as well, since these are 3's, you just multiply what's underneath. So we're going to have the cube root. 9 times 7 is 63. And this is going to be x. 7 plus 4 is 11. So we look around for this answer. We know it's not that one because we still have an 11 under here and they pulled out something here. Same thing here. We know it can't be that one. So it's either going to be A or none of these. Well, let's take the cube root of x to the 11th. What's the largest number that will go into 11 that's divisible by 3? Well, the answer is 9. So this would be the cubed root of 63 times x to the 9th times x squared, because 9 plus 2 is 11. Well, 9 divided by 3 is 3, so the cubed root of x to the 9th is x cubed, and then none of the rest of this you can take the cubed root of. So it's going to have to be x cubed times the square root of, it's going to be x cubed times the cubed root, I forgot to put the cube there, of 63x squared. So the answer is going to be A. Alright, the answer is going to be A. Alright, now number 7. Okay, 270 nor 5 are perfect cubes. Alright, so what we want to try to do is divide 270 by 5 to see if we can come up with a perfect cube. Okay, so basically what we're going to do is we're going to change this into the cubed root of the entire thing. 270 20 x to the 20th divided by 5x. Well, 270 divided by 5 is 54. And x to the 20th divided by x is x to the 19th. Alright? So now, the largest perfect cube that goes into 54 is going to be 27. And 27 times 2 is 54. And then what's the largest number that is divisible by 3 that is less than 19? Well, the answer is 18, so it's going to be x to the 18th times x. So now let's go through and take some cube roots here. Cube root of 27 is 3. You can't take the cube root of 2, but the cubed root of x to the 18th is simply 18 divided by 3, which is 6. So it's going to be x to the 6th. And now the cubed root of 2 times x. So the answer is B. Alright. So when you have exponents like x to the 19th there and you're trying to take the cubed root of that, all you have to do is find the largest number that is divisible by 3, in this case, that is smaller than 19. Well, 18 is the largest number divisible by 3 that is smaller than 19. So we broke the x to the 19th into x to the 18th times x. And then, of course, the cubed root of x to the 18th is x to the 6th, because 18 divided by 3 is 6. Okay? Alright, let's keep going. Let's go to number 8. What is the simplest form of the radical expression? So, when your indexes and your radicands are the same, all you do is you add the coefficients in front of the radicands. So this is just going to be, since the radicands are the same, we know our answer is going to be the fourth root of 2x. Okay. Make that a little smaller. We know it's going to be the fourth root of 2x, and then 2 plus 6 is simply 8. So it's 8 times the fourth root of 2x. Alright. Oops, I almost forgot about number 9. Number 9 works the same way number 8 did. Our indexes are the same. Our radicands are the same. So 3 minus 6 is negative 3 times the square root of 2. Alright. Alright, number 10. At first glance, you might say this isn't solvable. You can't add these together because all the radicands are different. That's true, but let's try to get the radicand the same. Well, what's the largest perfect cube that'll go into 48? Well, let's see. 6 times 8 is 48, 8 being a perfect cube. So let's start there. So this is going to be 3 cubed root, I'm sorry. It's Friday, I'm ready to go home, guys. The cubed root of 8 times 6, so that'll give us the 48. The cubed root of 8 is 2. So this is 2 cubed root of 6. Now, the reason I started with the smallest number is because now we know the number that has to stay under the radical. And if we can't get it for one of the answers, we know it's not solvable. All right? And we know that that number that has to be there is 6. So we need to find the cubed root of something times 6 that equals to 2058. So just take the 2058 and divide it by 6, and that gives you 343. Well, the cubed root of 343 just happens to be 7. So this will be plus 7 cubed root of 6. So now, for these two at least, we've got our indexes and our radicands the same. Let's see if we can do that with this. So we know that we're going to have to do times 6, so just do 750 divided by 6, and that gives you 125. Well, the cubed root of 125 is just 5 times the cubed root of 6. So now we have the cubed root of 6. 2 plus 7 is 9, minus 5 is 4. So the answer is 4 cubed root of 6. So the answer is A. Alright? Not too bad. So anytime your indexes are the same like this, but your radicands aren't, try to simplify down the radicands so that way you can get the same radicand for each one of them, and then you can add them together, just like we did here. Okay? That's what you want to do. Alright, number 11. What is the product? Well, anytime you're multiplying together two numbers like this, you just simply FOIL them, just like you would if it was like x plus 3 and x minus 5 or something. So 7 times 8 is 56. And then 7 times the square root of 2 is just 7 square root of 2. And then this is just minus 8 square root of 2. And then negative square root of 2 times negative square root of 2 is simply negative 2. Now you just add together your like terms. 56 minus 2 is 54. And then 7 square root of 2 minus 8 square root of 2, 7 minus 8 is negative 1. So this is just going to be 54 minus the square root of 2, which is B. Alright. So again, when you're multiplying together two numbers like this, you just simply FOIL them together and then combine your like terms. Alright, you'll always be able to combine your like terms. Alright. Let's keep going here. Number 12. How can you write the expression with a rationalized denominator? Alright, so this one's pretty simple. All you do is multiply by the conjugate of the denominator. To get the conjugate of the denominator, all you do is flip the sign between the terms. And make sure you multiply the top and bottom by the same thing. Alright? So now this here simply comes out to this first term squared minus this last term squared. The reason it's minus is because positive square root of 6 times negative square root of 6 is negative 6. Alright? So this is going to be the square root of 3 times the square root of 3 is 3 minus Square root of 6 times negative square root of 6 is 6. Alright, so that's going to be a minus 3 on the bottom. Now, you just got to follow the top. Square root of 3 times the square root of 3 is 3. Square root of 3 times negative square root of 6 is negative square root of 18. And then again, you get another negative square root of 18 there. And then negative square root of 6 times negative square root of 6 is positive 6. So now, combine your like radicals. 3 and 6 is 9. Minus, you have 2 square roots of 18. They're both negative. So it's minus 2 square root of 18. Alright, let's keep going because we're not in simplest form yet. 9 minus, well, 18 can be broken down into 9 times 2. The square root of 9 is 3. 3 times negative 2 is negative 6. And of course, this is going to be the square root of 2 over negative 3. Both of these numbers are divisible by 3. So 9 divided by negative 3 is a negative 3. Negative 6 divided by negative 3 is positive 2. And of course, the square root of 2 just has to come along for the ride. So that's your final answer. So it looks like C is the answer. Alright, C is the answer. Alright, number 13. Again, we've got to rationalize the denominator. The easiest thing to do here is this. We want to get 6 to have an exponent of 3. Right now, we just have an exponent of 1. So what we're going to do is we're going to multiply by the cubed root of 6 squared. That way, it'll give us 6 cubed, the cubed root of 6 cubed when we multiply them together. And of course, what you multiply by the bottom, you have to multiply by the top. So this comes out to the cubed root of 6 cubed, and this comes out to 2 times the cubed root of 6 squared plus the cubed root of, let's see, that's 36. And then 36 times 3 is 108. Alright. So therefore, on the bottom we have 6. This has to stay 2 times the cubed root of 36 because there's no cubed root into 36. And then the 108 can simply go into 27 times 4. Cubed root of 27, of course, is 3, so that can come out, leaving the cubed root of 4 underneath. So this should be your answer, 2 cubed root of 36 plus 3 cubed root of 4 over 6, so it looks like the answer is D. Alright, that's all there is to that one. Alright, moving right along, let's go to 14. Alright. Write the exponential expression in simplest radical form, or just in radical form. Now, this one right here, the 3 is going to be outside of the parentheses. Alright, the 3 is going to be, outside of the radical because there's no parentheses here. If there are parentheses here, this 3/8 would also be distributed to this 3. But since there's not parentheses here, this 3/8 only affects x. So we can roll out b and we can roll out d because here, since the 3 is under the radical sign, that means you distributed the 3/8 to the 3, which you weren't supposed to do. And here, since we have the exponent of 3/8 on 3, you did the same thing. In fact, b and d are mathematically equivalent. So now, is the 8 on the outside or is the 3 on the outside? Is it the 8th root or the cubed root? Well, since 8 is in the bottom, that means it is the 8th root. And the 3 is in the top, so it's going to be x cubed. And then, of course, this 3 is just simply multiplied by all this, so he's going to be out front. Alright, he's just going to be out front. Alright, write this in exponential form. So the first thing I would do here is I'd go 8 over x raised to 15 over 7. That's the first thing I would do is change the bottom to exponential form. Now, if you notice here, we have a couple with negative exponents, we have a couple with positive exponents, but the only place we have a fraction is in the exponent. Here we have the entire problem is a fraction. Well, how are we going to get this up here? Well, the way you do that is all you do is take your exponent and change the sign. So this is a positive 15 over 7, so we're going to change it to a negative 15 over 7. All right, so now this is gone down here because we moved it to the top, and remember, to move it to the top, you just make the exponent negative. So it's 8x to the negative 15 over 7, which is letter C. All right, which is letter C. And the same thing if you wanted to go to the top to the bottom. Anytime you want to cross that fraction bar, all you do is change the sign on the exponent. That's all you do. All right, number 16. What is the simplest form of the number? So the first thing we need to do is change negative 1/2 to a fraction. Negative 1/2 in a fraction is negative 3/2. So now it's negative, so we know it's going to be in the bottom. So it's going to be 1 over 49 to the 3/2. So we can roll out B, and we can roll out D, because they're negative and our number is clearly positive. Plus, there's no fraction either. So now this is simply going to be the square root of 49 cubed. Well, what's the square root of 49? The square root of 49 is 7. So this is 7 cubed, which is 343. So our answer is 1 over 343. So the answer is A. Alright, the answer is A. Alright, I'm going to go ahead and do 17 as well since it's in this same section. And then we're going to call this video finished. Alright, so it says write that number in simplest form. Alright, so since this entire number is in parentheses, we have to distribute this exponent through. Alright, so that means we're going to have 8 raised to the negative 2/3. And we're going to have A. Now, let's look at the exponents. When you take an exponent and raise it to another exponent, you are multiplying those exponents together. Alright, so it's going to be 3 times this, and the resultant of that is going to be our exponent on A. Well, negative and negative is positive, and then there's a 3 here, which cancels out with that 3 there, which just leaves us with 2 in the top. So this is just simply A squared. So again, we have a negative exponent. We know we're going to have a fraction, so we know it's not that one or that one. Well, it could be none of these. We'll leave that off for now. But this A squared here, he's going to stay in top. He's not going to go to the bottom. Only this term is going to go to the bottom, which means C is out as well. So now let's turn this around like it's supposed to be. This is going to be the cubed root of 8 squared. So it's going to be A squared over, what's the cubed root of 8? 2 squared is 4. So it's A squared over 4. Alright? Remember, when you see none of these as an answer choice, the chances of it actually being none of these is relatively small. Alright, so just because they include none of these all of a sudden, because like the first 16 I don't think had a none of these in them. All of a sudden they throw one in. Don't automatically think it's going to be none of these because it is rarely ever none of these. Alright? Alright, so I'm going to call this video a wrap because it's a little over 25 minutes long now. So feel free to watch as many times as you need to, and I'll make the next one.